Hi guys, welcome to my channel. This video is about 5G. In this video, I will explain to you about what 5G is. Firstly, I will go through a brief background about the previous mobile technologies like 2G GSM, 3G and 4G, and I will come to 5G to explain what uses 5G have. In the past few months, people have been talking about 5G all the time. We see about 5G in the media and especially the United States accusing the Chinese telecommunications giant Huawei about using 5G to spy on their countries. Also, since the coronavirus epidemic began recently, some people have been paranoid about 5G and its adverse health effects. Because of this reason, people have been setting fire to 5G mobile towers. So stay tuned to this video, and by the end of this video you will have a clear understanding about 5G and the uses it has to our future. Firstly, if you haven't subscribed to this channel, please subscribe now. Now I will give you a short background introduction to the mobile technologies that were available in the past. Mobile technologies can be divided into generations. First generation, second generation or 2G, 3G, and now we are talking about 5G. If we talk about 1G or the first generation, it was mainly an analog mobile technology. It was used in 1980s and 1990s. Analog means the information was sent in pure analog format. It used technology called FDMA, where one or two frequencies were allocated to each user. Now if you look at this diagram here you can see the mobile device that was used in those days. If you can remember, this was a very bulky and big device. So if this is one user, there was one frequency to transmit a signal from the mobile to the tower and another frequency to transmit signal from the mobile tower to the user. So each user required two frequencies. So if you had 100 users, you would need 100 frequencies. And that is why it was called inefficient, because frequencies, by the way, are very expensive and very limited. Also, 1G provided only voice. That means you could not use this device to browse the internet or Facebook. Facebook was not there anyways. And then the limitations were poor voice quality and the capacity. The capacity was limited because the frequencies were limited. That means the number of users that can connect to this mobile tower was limited by the number of frequencies available. And the voice quality was poor. If the mobile was far away or in a wooded area or in a rainy day, the voice quality would be very shaky and not clear because it was using analog mobile technologies. Then came 2G. GSM was the main 2G technology. It was first standardized by the European Telecommunication Standard Institute. The importance of 2G or GSM is it was the first fully digital mobile system. In addition to voice, it provided services like SMS or short messaging service and MMS, multimedia messaging service. And when comparing to 1G, the voice quality of 2G was better because it used digital systems and digital correcting systems to make up for bad voice quality. 2G also provided data system services with 2.5G because 2.5G had the service called GPRS, General Packet Radio Switched Service. GPRS provided some sort of data service where users were able to browse the internet. Then these speeds were improved in 2.75G with the introduction of edge technology. Today, 2G is very rarely used. Almost most 2G services or GSM services have been terminated. But I can tell you, in my country, Sri Lanka, 2G is still operating. Next came 3G. 3G was first specified in IMT 2000 specification by the International Telecommunications Union or ITU. ITU is the United Nations body for regulating telecommunications. There are mainly two technologies in 3G called UMTS and CDMA 2000. But UMTS is the most widely used technology. It uses the technology called WCDMA or wideband CDMA. In 3.5G, HSPA was introduced. HSPA stands for high speed packet access. In 3.75G, HSPA Plus, which is an improvement to HSPA, was introduced. Now I will introduce you to the concept of cells. Cell is usually the geographic area covered by one mobile tower. Cells are usually represented by the hexagonal shape, and the mobile tower is located at the center of the cell. In this diagram, you can see three cells, and each cell is colored by a different color. This is because each cell is using a different frequency. This is used to minimize the interference between cells. And if you come to this cell, you will notice that there are two sizes of cells. These cells are smaller than these cells. This is because the population density around here is higher than around here. So there are more people using mobile phones in this area than in this area. Therefore, you need more mobile towers. That means more capacity. And because these cells are smaller, you have to use low transmission power in these mobile towers. Whereas when you go to low population density areas, the cells become larger and use high transmission power. High transmission power is used because you need more power to reach the cell edges. In the urban areas, low transmission power is used to minimize the signal from these cells reaching too far away. Also, you can see there are a lot of frequencies used, thus more colors. This is called frequency reuse. So the same frequency is used far away from the cell. If you see this red color cell, this frequency is used few cells away from it, again in this cell. Therefore, these two cells do not interfere with each other. The same goes to these cells and these cells and these cells. Also, there are something called small cells. There are microcells, picocells, femtocells, and attocells. And these are classified by their cell radius. Microcells have usually less than 2 km radius, and attocells are the smallest with 1 to 4 meter radius. Next, I will explain you the architecture of 2G technology. If you take a 2G network, there are two main parts, the radio access network and the core network. Radio access network is where the mobile phones connect to base stations, and the base stations connect to the unit called the BSC or base station controller. If you come to here, you will see two mobile phones. These are 2G mobile phones. If you recognize, this is the old Nokia mobile phone and this is the iPhone 1, which was a GSM version. So these mobiles connect to the base stations and the base stations connect to the BSC via radio links. Then the BSC is connecting to the core network. If you take the core network, it has two parts, the packet switched parts and the circuit switched parts. The voice data, that means if this mobile user wants to call somebody, that is voice. That voice traffic is routed to the circuit switched part. While if this user wants to browse the internet, that traffic is packet data. That Packet traffic is routed to the packet switching network. The packet switch network connects to the packet switched external network, which is usually referred to as the Internet. And the circuit switch network connects to the circuit switch network, which is the public switch telephone network. Now I will explain you the 3G architecture. If you take a look at this 3G architecture, you will see a great similarity with the previous 2G architecture. However, some names have changed. The base station has changed to Node B and the BSC has changed to RNC. The core network retains the packet switched and circuit switched data network separation. The other change is the AR interface between the mobile device and the Node B. This used WCDMA, as I explained you earlier. Next, I will explain you 4G. 4G, or more commonly known as LTE or long-term evolution, was standardized by the 3GPP Release 8, released in 2008. 4G was the first all-IP mobile network, meaning it was end-to-end IP. That means the mobile device also had an IP, so as all other network elements. There are two main forms of LTE. They are TDD and FDD. TDD is where the uplink and the downlink are separated by time, where FDD is where the uplink and downlink are separated by frequency. Also, LTE uses OFDMA in downlink and single carrier FDMA or SC-FDMA in uplink. LTE also provides spectrum flexibility. There are these bandwidths available in LTE, and this provides more flexibility to the design of the network depending on customer requirements. That means the capacity requirements, you can choose either 1.4 MHz, 3 MHz, 5 MHz, 10, 15 and 20 MHz bandwidths. Also, it is important to note that more bandwidth means more capacity. You can fit more users in this than in this. Also, LTE uses MIMO. This is multi-input, multi-output antenna configuration. There are 2x2, 4x4 and other antenna configurations. 2x2, for example, allows two beams uplink and two beams downlink. This is antenna diversity, which increases the data speeds. If you come to this diagram, this represents this is called a resource block in LTE, in downlink. This represents the basic structure or interface structure of LTE. This has two domains, time domain and frequency domain. And time domain is usually 0.5 milliseconds long. This frequency depends on the bandwidth you choose. If you choose 5 MHz, this will be 5 MHz. And these small blocks are called resource elements. This is the smallest element in LTE AR interface. This is where all the bits are stored. The number of bits stored in this depends on the modulation technique used, either BPSK, QPSK, 16PSK or 64PSK. By the way, the modulation technique used depends on the AR interface quality. Depending on the bandwidth used, the number of resource elements changes. That means the higher the bandwidth, the higher the capacity. That means higher resource elements. Now we will discuss about the LTE architecture. You will clearly see a difference between LTE architecture and the previous 2G and 3G architectures. Firstly, it is all IP. That means from end to end, it is all IP. Each of these elements will have IP addresses. Secondly, eNodes BS are connected. This was not the case in 2G or in 3G. One of the key improvements in LTE is the reduced latency. Latency is the delay when a signal has to go from the mobile device, the core network, and come back. Because eNode Bs are connected with each other, most of these delays are cut down, therefore increasing the speed. Also, when you come to the core network side, there is no packet switched and circuit switch separation. All data, because they are all IP, are treated as packets and they are all routed through here. Packet gateway or PGW deals with all the packet data. The MME or mobility management entity deals with mobility when the user or the mobile device is moving. So after discussing the previous mobile technologies from 1G to 4G, now I think we are ready to discuss 5G. 5G was first standardized in the IMT 2020 standard by the ITU, and it discusses three use cases: enhanced mobile broadband, massive machine type communications, and ultra reliable and low latency communications. Also, 5G is specifically designed to cater for IoT or Internet of Things applications. If you take about if you take enhanced mobile broadband, it is basically the internet broadband that we use, and the main improvement here is it should provide gigabytes per second data rates. And if we come to massive machine type communications, this kind of applications include smart cities and smart home buildings where there are hundreds and thousands of devices, IoT devices, communicating all the time. And the next and final use case is ultra reliable and low latency communications applications. This type of applications include self-driving cars, mission critical applications, industrial automation, and others. In these kind of applications, the reliability and low latency are the key. If you take a self-driving car, for example, it is very important for the self-driving car to have a low latency and ultra reliable connection to the server, because the self-driving car takes decisions always connecting to the server, and if the latency is high, the car will take longer to make the decision and resulting in accidents. And also the connection should be reliable, not just reliable but ultra reliable, so that the car is always connected to the server to make the right decision at the right time. Now we will see how 5G is going to achieve the previously mentioned requirements. International Telecommunication Union or ITU's IMT 2020 standard describes that 5G should support 20 gigabits per second downlink and 10 gigabits per second uplink speeds. Keep in mind that these are just theoretical values, and in practice these values may never be achieved. 3GPP specifications described in Release 15 and Release 16 due in 2020 will describe the technicalities of 5G. 3GPP proposes using 5G NR or 5G new radio to be used with 5G. 5G NR describes FR1 or frequency range 1 and FR2. Frequency range 1 uses frequencies less than 6 GHz and FR2 uses or millimeter wave uses frequencies greater than 24 GHz. Also 5G will be using massive MIMO or multi-input multi-output antenna configurations. These will increase antenna diversity and reduce interference, thereby increasing data speeds and data quality. Also 5G will be using small cells. Because 5G is going to use higher frequencies like millimeter waves, it will increase path loss, thereby minimizing the distance that 5G antennas can transmit signals. Therefore 5G should use small cells. And if you take a look at this picture, This represents a 5G small cell. 5G small cells will usually be mounted on light poles along the streets. 5G also be using beamforming. Beamforming is a technique that will direct signals towards the user. This will improve speed and the signal quality as well. An important change in 5G is the use of software-defined network and network function virtualization. This is mainly used in the 5G core network, where the network will employ a technique called network slicing to create virtual networks for different applications to meet their specific application requirements. So this is a very simplified diagram of the 5G architecture. You have the control plane and the user plane, and the core network which you see on the top is a software defined network, and it has all the software defined network virtualization functions, and the cells are referred to as G-node Bs, and the user plane function defines all the user plane data. And this is, as I said, is a very simplified representation of the 5G architecture. If you need an in-depth or detailed knowledge, information about the 5G architecture and how it operates, you can just use, there are plenty of online resources. You can go ahead and look it up for yourself. I think it will be out of the scope of this video, and I hope that this diagram gives you a simple and understanding of the 5G architecture. 5G is still a developing technology. As I explained you earlier, the release 16 is due to be released this month, and 5G is still evolving. And although we have some 5G deployments going around, I think 5G is yet to develop itself more refined and more updated technology, or 5G networks will be coming in the near future. And there's a great deal of discussion about privacy and security are the main issues at the moment, because 5G is directly applied for IoT and other applications. It has to be secure. So the security aspect of 5G is the most important and critical point of discussion at the moment. That is why we see all these countries talking about Huawei and the security related issues regarding the 5G. That is why 5G is coming up and is a big topic, a hot topic these days. So I hope that you learned something out of this video, and if you like this video, hit the like button, and if you haven't subscribed to my channel, please subscribe by clicking the subscribe button below. If you have any questions, please leave a comment and stay tuned for more videos like this. Thank you.